x equal to, we will get the value of the y, something. So what will be happen? Intersect will be, using the intersect we are able to avail about this one. What is the value of the y when we change the value of the x? That we call the intersection. And what is the formula? Y equal to mx plus c. What is the formula? Y equal to mx plus c. Now sometime what will be happen? We will get the some kind of the error between predicted value and the observed value. We know last time we take the Dexcom. Am I correct? You don't know about the Desmos. So now see, here in the Desmos, suppose I am writing the one line. See, I am writing here y equal to mx plus c. So this is the what? See, this is the linear regression. Now suppose I am writing the some values. I know 1, I am writing 10, 2, what I am writing here? 20, and 3, what I am writing here? 40, and 4, what I am writing here? 50. Are you getting my point? Yes or no? And now I will draw the point. Net is slow. So what will we get here? What we get here? 10, 20, 30, 40, 50. And we know we are already easily predict this one. What is the position on the 5? What we get on the 5? 6. What we get on the 5? 10, 20. Sorry, here I am writing the 30. Okay, here I am writing the 40. And what we get on the 5? We can easily say. What happened? We are able to easily say this one. What we get on the 5? 50. So this, if we are getting the continuous prediction, there will not get any kind of the error. Now sometime what happen? We will not get the value in the form of the sequence. Maybe we will get the some kind of the error. So what happen where we get the error? If we are getting the difference between the actual value and the predicted value. Are you getting my point? So that we call the error, or we can say residual. What we call? Error or residual. So what is the error? Why this is not printing? Now see, everyone getting this line? Hai? So now suppose I am writing here, I am writing the mx equal to 10. Now see. Now 9. I think 1 is enough. 1. So what happened? Intersect is what we are taking the intersect only 1, because this is accurate. Am I correct? This is accurate. Now what I am taking? I am taking the one little bit advanced step. 1 equal to I am writing 20. Getting my point? And then 2 equal to I am writing 30. And 4 equal to I am writing here 40. And now 4 equal to I am writing 50. Now you can see what we are getting. Yes, just you can see the line. Are you getting my point? So what happened? Actually, I want to predict here on the 5. I want to predict the 60, but it is predicting near about the little bit different. Are you getting my point? Now see, suppose I am writing here 5, and what we get here 60. But see, you are getting a different actual value. What happened? I want to suppose I am writing here c equal to 10. Now it will get the correct. Are you getting my point? So this one we call the predicted value. This one is the predicted value. Are you getting my point? Now here predicted value and actual value is getting matched. Am I correct? Suppose I am writing intersect equal to 1 only. If I am writing 0, what we get? C. We are getting little bit difference. You can see. Getting 0.1 difference. I hope you are getting my point. What we are getting? 0.1 difference. So what should be what will be the, what we can say, what will be the actual value? Actual value should be 50. Am I correct? But what we are getting? See, we are getting little bit different. Are you getting my point? So that's we call the residual. That's we call the what? Residual. So residual means nothing but a difference between actual value minus predicted value. Are everyone getting my point? Everyone getting my point? So what happens? See, now we are getting the difference. Now how can we calculate the difference? How can we calculate difference? Actual, this one is what? 4. See, actually this one 1, 2, 3, 4, 5. This one is 5. But where are getting? On the x-axis 6. Everyone know about the graphs? So what we do? What we do? Actual minus what we get? Minus 1. What we need to do? What we need to predict actually? 5. But what line is predicting? 6. So what we get answer? Minus 6. This is the residual. Are you getting my point? So if we are changing the value in the sequence, but now you can see the one another difference. Now suppose I am writing here. Suppose I am writing. Assume this one. I am writing here 21. Getting my point? Now here suppose I am writing 32. 32. Suppose here I am writing again 41. Suppose again here writing here 52. And now suppose again here I am writing 61. Now see what will be happen. Now see what will be happen. Now suppose I am writing here 2. I am writing here 3. I am writing here 4. I am writing here 5. I am writing here 6. Now see. I will take little bit bigger. Okay. Suppose I am writing here 23. And now here I am writing here 31. Here I am writing suppose 44. Here I am writing suppose 51.5. Okay. And now here suppose I am writing here for example 65. Now see. Everyone getting my point? Just try to understand the things. Try to understand the things. Now see what happened on the 7. See where is the actual okay. Now see this one is a line. This is the predicted line. Are you getting my point? Now but what happened? Point getting in the in a line? No. Why? Because if you are to line from this one point, we will get a little bit zigzag kind of the line. Getting my point? So what happened? Always, what is the linear regression? It will predict the only linear line. Are you getting my point? So what happened? Sometime this point will be get out of the bound. So what we call that? We call the error, or what we call residual. So now what happened? See, now suppose I am taking one position. Suppose I am saying here we have a 10. On the 10, what we need to predict? On the 10, what we need to predict? It should be the 100. Are you getting my point? But you can see for the 10, it is going little bit. See what happened? Actually, it is predicting the 100. But if we go this scenario, what we get? Maybe we get the 10 value 100 or 5, 100 or 3 or 100 or anything. Are you getting my point? So now, if we are getting this kind of the problem, that's what we call residual. What is residual? The difference between actual value and predicted value. Are you getting my point? So now see, now suppose I am drawing the line, some point. Now we will take the, for example, you can see here, for example, where is it? For example, I am just marking the point. Some one point is here, 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 one point is here. And now see here, what is happening? This point is little bit too much away. Are you getting my point? So if we draw this kind of the line, this point is nearest, but what happened? We need to take the all points should be nearest. So for that, what we create? We will create the mean of the all point. Are you getting my point? So means what happened? We will find out the distance of this point to this point. First one we will get the residual number 1, residual 2, residual 3, residual 4. Then we get the residual what? 5, residual 6, residual 7, and residual 8. Are you getting my point? Now we get the sum this one value. So what we do? We will divide by the n. N means total number. So now for example we get here 50. and we divided by the 50 by the, suppose we have 5 points. So what will be happen? We get the 10. So what will be happen? That the line will be drawn into this manner. The all point will be should be the nearest to the line. Are you getting my point? So what happens? So that's why we will get the near about the nearest prediction. Are you getting my point? Everyone understood? So now see if how we can draw this one. For that we have some kind of the measures. Are you getting my point? That is this one. MAE. What is the MAE? Mean absolute error. What we call? Mean absolute error. So what is the mean absolute error? So means simple. Now if I want to draw the line, we are going to create the mean of the residual. Are you getting my point? We are going to create the mean of the residual. Suppose actual value is for this one scenario. For this one scenario, what is the actual value? For this one scenario, see, this one scenario, what is the actual value? Here for the 6, what is the actual value? For the 6, what is the actual value? 65. Am I correct? But what is the actual value for the 65 is the 6. Am I correct? But what we are getting? What we are getting? We are getting near about the 6.5. Am I correct? So what is the mean here? 0.5. Am I correct? First one residual. Now for the 5, what will be the actual value here? What will be the actual value? Actual value should be the 5. But what we are getting? What we are getting actual value? See, actual value is the 5. But what we are getting? Predicted value near about this. What happened? 5.3 or something. Am I correct? What we are getting? See, this is a 5.5 and here we get is a 5.1 something. So now for this one, what we get? What is the actual minus 1? So what we get? Suppose 0.1. Am I correct? And now just go for the third one also. Go for the third one, 4. What is the predicted value for the 4? What is the predicted value for the 4? See. What is the predicted value for the 4? No, sorry, you are already done. Okay, I will do it again. Just try to understand that thing. What is the first one? We will go the one by one from the bottom. So now see, what is the value for the 2? What is the actual value? What is the actual value? What is the actual value? 23. Am I correct? What is the actual value? 23. But what we are predicting, sorry, for the 23 answer, what is the actual value? 2. Sorry, just one. What is the actual value? 2. What is the actual value? 2. But now you can see here what we are predicting. What we are predicting? We are predicting near about the, see, it is a 2. What we can say? We are predicting near about the what? 2.2 or something. Am I correct? So what we get here? 2 minus, what we get here? 2 minus 2.2. So means first, what we get first one? 0.2. Correct? Then we'll go for the 3. What is the actual value? For the 3, what is the actual value? For the 3, what is the actual value? What is the actual value for the 3? What is the actual value? 31. See, for the 3, what is the actual value? 31. है ना? And now see what happened for the 31 on the y-axis 31 and on the x-axis what we have 3. But what we are getting near about the 3.1. So what we say 3.3 minus 3.1. What we get here 0.1. Am I correct? What we get 0.1. Now go for the 44. What is the actual value for the 44? What is the actual value? What is the actual value for the 44? It should be the 4. See, actually getting the 4. But what we are getting actual value, what we are getting predicted value near about the 4.4. What we are getting 4.4. So what happened? 4 minus 4.4. What we get 0.4. Am I correct? Now for the 55. For the 55. For the 55. What is the value? What is the actual value? 51.5. For the 51.5, what we have? 5. But what we are getting actually? We are getting the near about the 5.2. So what we get here? What is the residual here? What is the residual? 0.2. Am I correct? Now for the last one. What is the actual value for the 65? What is the actual value for the 65? 6. But what we are getting? 6.3. What we are getting? 6.3 or 6.5. See, what we are getting? 6.5. So what is the residual here? 0.5. So we will get the mean of the all point. What we get? See the formula. What is the formula? What is the formula? Summation. Everywhere about the summation of the all. Y dash y1 means actual value and y dash means what happened? Predicted value. So we are going to take the formula and what is the n? N means how many points we have? We will divide by this one. So we will do the calculation and we will divide by the what? We have 500. That's why we divide by the 5. And it will draw the automatically what happened? The nearest to line only. The first one we will get the some value. That is the if the answer, what is the answer? 5, 7, 7 and then 11, 11 and 13, then 14. Suppose 1.4 divided by 5. What will we get the answer? What will we get the answer? 0 point something. 1.4 divided by 5. 0.28. What we get? 0.28. So means if we follow this linear regression equation, so each and every time we will get this kind of the average error. What we get? Average difference in the actual value versus predicted value. Are you getting my point? Because here we have already some kind of difference. Actual value, we are going to not take the accurate actual. We are going to take the nearest actual value. Getting my point? So how we calculate this one? Mean absolute error by doing the average of the mean. Second one, mean square error. What is the mean square error? So simple. What we are getting? 1.4. So if we are going to 1.4 by 5 and 5, and we are going to create the square. So this is the second one, mean square error. So here what we get? Here what we get? 0.28. Am I correct? Now just do the mean square error. So what I am doing? 1.4 divided by 5 and then how to take the square? Then I will do the square. Now see what we get the answer? 0.07. Got it? What we get answer? 0.07. Then what is the MSE? Mean square error. Then what is RMSE? Root mean square error. So this what happened? In the third one, first one we take directly 1.4 divided by 5. Second time we take the 1.4 divided by 5. Then third time 1.4 divided by 5 to square and this one root square. Getting my point? RMSE मतलब root mean square error. So now if I am taking this one root mean square error, what will get the answer? 0.28. You can use the calculator. What will get the answer? Root square error I am writing here 0.78. So now see what we get if we do the root square. What we get the answer? We get the answer 0.27. What we get answer? 0.27. Got it? So now this is the three methods. Now in which method we are getting the less error? Where we get the less error? Where we get the less error? Where we get the less error? Into the second one. Are you getting my point? So now if I want to calculate the error, this is the approach. So that we call the linear regression evolution technique. You can use the MAE, you can use the MSE, mean square error, mean absolute error, mean square error, and root mean square error. You can use the any one technique to do the regression. That's we call the evolution technique. Everyone got it? Everyone got it? So last time what we learned in the project, what thing we have completed? We already defined the data set. I will say. Now, just 5 minutes. We just complete this one. I will say. Okay. Now see. First what happened? We done with the define the problem. What is the problem? I want to predict house rent. Then we collect the data. Am I correct? Then we develop the machine learning model. So which one model we used last time? We used the linear regression. Then what we use? Which we use? We use the three models now. Random forest regressor, and then third one decision tree regression. What we use? These three are algorithm we use for the what happened linear regression. And you know what happened? We get the in the random forest we get the good accuracy, high accuracy. That's why we test that model. So for testing the model, what we create the .pickle file. Am I correct? What we created last time? .pickle file. So we know what happened. Linear regression only understand the numeric data. What happened? So first one, what we did? We create the first one encoder. What is the encoder use? Encoder convert the text, matlab quantitative data into the qualitative data into the quantitative data. Then what we get is we are getting the large number. So for that, what we do? We use the scalar. Am I correct? What happened? Scalar is going to mean scalar. So what happened? It will convert this one number between the 0 to 1. Am I correct? So what happened? What is the 0? 0 means false. 1 means correct. So we convert this one into the scalar. And then we create the model. Which one model? Which one we use? Linear regression. Am I correct? I think that time we get the accuracy in the random forest regressor. What we get accuracy in the random forest regressor. So we create the pickle file for the encoder, for the scalar, and for the model. So that's what we call. We call the testing the model. So model testing is done. How many model we get? We get the 3 model. Now this 3 model we need to deploy. Am I correct? So for that we already deployed on the Streamlit, but that time we create onto the local host. Am I correct? Now we are going to make the project live. What are we going to do? We are going to make the project live. Am I correct? So now for that thing, first one, what happened? We need to push our code onto the GitHub repository. So now open the GitHub, and I hope how many created the repository? Good. So now open the GitHub. Open the GitHub. Now I'm creating the new repository. I'm giving the name. I'm writing the Kite college name because I have already some repository for the house prediction. What I'm writing here? Kite house rent prediction. House rent prediction. Got it? Now what I'm doing? I'm creating the create repository. Created. Everyone done with the repository creation? Done. Now go into the VS Code. And where is our project? House rent prediction. Now show more option. Open with VS Code. Open our project in a VS Code. Now see, here what happened? We already, now there is no use of the which one? IPYNB file. Are you getting my point? Why I am saying this one? Now, no need to use the IPYNB file. Why I am saying this one? Because in the IPYNB file, you can see the last one. We create the model. Which one model? See, we create the 3 model. Random forest regressor, decision tree, and then linear regression, and we check the models. Where we get the accuracy? We'll get the accuracy into the random forest regressor, good one, 93.75. So that's why what happened? We deploy only which model? RFR. Am I correct? So now here we done with the testing. Am I correct? Where we do the testing, we do the testing manually. Am I correct? We done with the testing, then we deploy the model. What does it mean? What deployment model means? Here, what I'm doing, out of the three, which is giving the good accuracy, random forest regressor. Am I correct? So that's why I create the pickle file of the model. What is the pickle file? So means what happened? We are going to create the one model. Now this one file we can able to use anywhere. Are you getting my point? So means यहाँ पे see we get the prediction. Now this model, this rent model.pkl, he is aware about the how to do the prediction. Are you getting my point? So now we know, we take the dinner. After taking the dinner, stomach is get satisfied. So what happened? Now we will carry the plate this one to the everywhere. No. So what happened? This IPynb file is working as the plate. So already we take the what happened? Three machine learning algorithm, and we already feed them a data. Which is the data? That is already the data frame, CSV file. We feed them a data, and this one model give us the good prediction. That's why we are using this one model only. So now that's why what happened? After using this one model, we get the three pickle files. So now why we get here three pickle files? First one is the encoder.pkl. You know this one file? Yes. So what is it of the encoder.pkl file? It will encode the text data into the, it means it will convert the text data into the number data, and then we'll get the large number that we need to do the minimum scale. For that what we use? Scalar that pickle, and then rent model. What is the rent model? For predicting the rent. Am I correct? Everyone getting my point? Now see what happened. I want to deploy the things. What I can deploy? I will deploy only 1, 2, 3. That is enough. But for the information, I am adding this one file also. There will be no issue. Are you getting my point? But we are going to use only these three files. And what is the app.py file? This is nothing but the front end file. Why front end? Because we write down the all, which one code here? Streamlit code. So what I want? House PNG. Then what I want the title. What is the title? House rent prediction. Then I want the title. Then I want to write the predict the monthly house. Am I correct? And now if I want to test this one, what is the command? What is the command? Not a Python yum. Only write down the streamlit run dot. Why I am executing app.py? If I want to execute the HTML code, which file you execute? The HTML file. Am I correct? So where is the streamlit code now? Where is the streamlit code? Into the app.py. Am I correct? That's why I am executing the app.py file. Now execute the app.py file. Execute the app.py file. So what happened? We'll get the window. But you can see into the URL box. Now here what we are getting? Here what we are getting? We are getting any live link? No. What we are getting? Local host. What is the local host? Anyone? What is the local host? Means we are deploying the project onto the local system. Am I correct? So if I execute this one file, so what happened? I am only file only in the system. Why? Because see, here input data is not defined. Why? Input did not define line 43 statement. Just 1 minute. Now say, what happens if I click on the predict? What we are getting? We are getting the red. Am I correct? So now, but you can see this one. Where we are executing onto the local host. But what I want a live link. Am I correct? What I want? Live link. So if I want to make the project live, what happen? We need to use the Streamlit cloud. What happened? Streamlit cloud. Everyone just go on to the Streamlit cloud. Create the account on the Streamlit cloud. Streamlit cloud login. You will get this one window. Everyone, I want to deploy the project. I want to make my project live. What I want to do? I want to make my project live. Everyone done? Everyone done? Everyone done? Now click on the sign in. Click on the sign in. And now continue. I already done. So continue with the sign in. And do the sign in or login with the GitHub, not with the Google. Why with the GitHub? Because the code that is available on the GitHub, we need to push into the Streamlit. Are you getting my point? Now continue with GitHub. Everyone continue with GitHub. So now in the Streamlit, what will be happen? You will get the same name as the GitHub. See what I'm getting? Rishi 93. Everyone done? Everyone done? Done? You need to open the two things simultaneously. First one GitHub, and then what happened? Second one is the Streamlit. After the login, you will get this one. I want everyone to get this one option, create app. Everyone done? Everyone done? Streamlit login. Streamlit cloud login. Streamlit cloud login. How many people done? How many people done? Good. Streamlit cloud login. Everyone do the login. Nido file send it. Everyone done? How many students done? Good. This is very simple. Done? Now see, we have a GitHub account. Yes. So we created this one, Git house rent prediction. Now what happened? This one repo we need to integrate here. But in this repo any data now? No. First what happened? We will insert the data. So for that, what I'm doing? What is the command? Everyone know what is the command? What is the command? What is the command? First one, git what? Init. Git init. Then git hyphen git space add space dot.
attendance,
Which attendance?
daily attendance sheet or
Daily attendance sheet. This is the total student, na?
no, daily attendance you make absent present.
Ha. Okay, this one is I'm directly mentioning the LMS only. I will put that attendance. Okay, I will select send that one. Okay, so here you will not get a day wise. You will get only percentage. How many percentage is attended? Okay, I will share that also. Everyone done? Git add dot. Now then, what we use? What is the third command? Git commit. What is the command? Git commit. Then what? We need to write down the git remote add origin. We already learned this multiple times. Then what is the third command? After what is the fourth command? Git push branch main. Then what is the last command? What is the last command? Bolo git push. Done. Now code is added to the git. Code is added to the git. Everyone add the code into the git. Everyone add the code into the git. Everyone add the code into git. Code added. How many should added the code? 1, 2, 3, 4, 5, 6. Bus. हाँ. Good. Now code is added. Now you can see the GitHub. Now see in this GitHub repository what we have? We have a code. Am I correct? Where is the code? Code is available into the which branch? C. Which branch? Main branch. How many branch we have? We have only one branch. Am I correct? Hello. Yes. Hello. बोलिए ना. Yes. Hello. हाँ सेशन हाँ बोलिए ना. हाँ. Just 1 minute. 1 minute. Just everyone do the one thing. Just push the code on the GitHub. Okay. हाँ बोलिए ना. Hello. Okay. अच्छा मतलब कि अच्छा मिला ना कि निगेटिव मिला. हाँ ओके थैंक यू. काकीनाडा मेरा वैसे देखो 30 तक है, तो यहाँ पे अगर 30 तक ही शेड्यूल है तो मैंने उनको कहा है कि अगर 30 का तक अगर खत्म नहीं हुआ वी आर गोइंग टू एक्सटेंड फॉर दी 1 डे अप टू द 31st. तो बट यहाँ पे प्रॉब्लम ये आ रहा है कि वेडनेसडे को इनका हॉलीडे है और वैसे भी 31st भी है, तो बच्चे आएंगे कि नहीं, दिस इज द वेरी डाउटफुल सिचुएशन फॉर द टीपीओ एंड फॉर द मी एज वेल. कहाँ पे? तिरुपति. अच्छा कब जाना है फिर? कभी 29 से डायरेक्टली अगर वहां पे तो कंटिन्यू हो जाएगा ना रश्मि. क्योंकि अभी देखो पहले वाइफ को कहा था मैंने कि 22 को आऊंगा, फिर उसको प्लान बना दिया कि एटलीस्ट 30 को आएगी. अब अगर उसको ये बोला तो मैं क्या ही बोलूं. हाँ वही ना, वही सीन. अरे बाकी कुछ नहीं, आपको तो पता है कि मैं रेडी रहता हूँ. तो मुझे लगा कि आप बोल रहे थे ना मुंबई वाला कि मैं 3-4 दिन वहां का कभी कर 5-6 से नहीं कर सकते स्टार्ट.